Hello and welcome to CS230 Web Information Processing. This is week 7 and this is lecture 13, and this one is an overview of database-driven web development 1. We'll have another overview next week, part 2, and today I'm going to talk about relational database-driven web development. And we're going to use relational databases, and then we're going to repeat a lot of this a little bit later with MongoDB for collection-based databases. And hi, Dean, thanks for coming. So let's press on. We have a lot to cover today, and I'm going to work through this as quickly and comprehensively as I can. So we're into the third section of the module. We are now looking at this overview, a set of database-driven web development. We're going to look at today and in the pre-recorded lectures as well. Then we're going to look at different kinds of architectures, LAMP, mean, and MERN in week 8. And then we're going to look at, in week 9, progressive web applications versus single-page applications. So we've a lot to get through, and we'll just work with the relational one today. We're going to focus mostly on database design for use with the web, applications that are built around a relational database. This is called a LAMP architecture. For example, Linux, Apache, MySQL or MariaDB, and PHP, Perl, Python, any of the Ps that will work fine for us as well. So we're going to review some architectures and how we could use PHP, traditional LAMP architecture, and also Node.js to interact with a relational database. So we will review a basic design for an online system for recording customers and their addresses, physical billing, and shipping and so forth. You're going to need these for assignments a little bit later. And I will show you my setup as well so that you will be able to have something similar and make it work for yourself. So let's get straight in there. So LAMP, we talked about it before. LAMP is really HTML, CSS, and JS. And then we have a server-side Node.js. So the front end is HTML, CSS, and JS. We know this already. Server-side Node.js. And then we have MariaDB as the database. And we've spent some time looking at PHP examples as well. And I did recommend that you install XAMPP because it provides you with all of these servers that we would need. So for example, you can see that I have a MySQL database running. It's MariaDB. I have an FTP server which is not running, and I have an Apache web server here. And I know they're running. I can go to a web page and I can look and type in localhost. Let's not look at 9000. And here, this is the XAMPP installation. And if you can do this, then you're pretty well set up for your work. In order to have an online database that's accessible from anywhere, though, and this will be necessary for your assignments and for your solutions, you need to have access to an online relational database. And in the department, we will provide you with this later this week. But when you go to log into your computer science account and you click on profile, you should see a profile information section here. You won't see this section just yet on database details because they'll be created for you this week. And if you click on this, it should give you the details. So I'll show you my details with some clear password information disconnected. So we have this web server called webcourse.cs.num.ie. You can go there, you can log in with your normal username for CS, and the database will be CS230, and you'll get a password. And that will allow you to be able to build web-based applications that access a relational database, and they can be accessed from anywhere, and this will last for the rest of the semester. So you can click, you can go directly through to WebCourse, and you'll be able to see it's here, webcourse.cs.num, and you can log in, and you'll be able to see that there's a CS230 link here. And if I click into CS230, I'm logged in as me. And we have our full database, and you'll see my CS230 database here. You'll see the tables that I have that I use for my examples. And this is the sort of thing that you'll have available to you. So if you don't want to install, or in addition to installing, I should say, your manager for XAMPP, then we have this set up for you as well, and you'll be able to use it for your assignments. And I'd recommend that you use it. So that's the state of play, and that's where you need to be in terms of setup. Now, you have all taken a database course, so we don't have time to do a lot of revision, but we will do a little bit of revision, and you'll see that in the pre-recorded lectures where I do revise some of this for you. So LAMP normally utilizes Linux, which is the operating system, and not just the kernel, but all the other components of the operating system. Apache, which is the web server. MySQL or MariaDB, which is the database management system. And P, so for PHP or Perl or Python, some scripting language, and you can use lots of different languages. You can use Java, of course, as well, But LAMP offers one of the most effective and popular ways of developing enterprise-level web applications because it's flexible, it has customization, and it's really cost-effective. So for personal development, I recommend that you use the Apache Friends XAMPP installation, as I mentioned already. It has everything that you need to be able to do to get started with LAMP development. We also wrote a Node.js HTTP server that functions in a LAMP mode. So we had AJAX calls. So typically Node.js apps form part of some mean or MERN architecture, and we see that a little bit later as well. So here's how the tiered architecture for building web-based apps will be working. Okay, and thank you for the good wishes in the chat there. And yeah, much better now. It's great to be back. Yeah, it's lovely, and thanks again for the good wishes. And I had lots of messages from students as well, and I really appreciate it. I know many of you have been ill as well, and it's been a tough year for everyone. We'll get there. So okay, let's have a quick look at LAMP and some of the architectures. So we have our file system. I'm using macOS on this particular machine. But I've used this whole XAMPP and LAMP architectures on Windows machines and Linux machines. So you can get like Raspberry Pis running Linux and install all this stuff on them as well, for example. So we have our file system, and then we have Apache, which is our core web server, and that talks or has an embedded libraries for PHP and Perl and Python. They sit on top of the operating system as well, and we have a database which will be MariaDB. So our browser then will talk to Apache, and Apache will talk to these middleware applications, software, who will talk to a database. Or our browser can talk to Node.js or Java or Python running a web server, and they will talk to a database. So there's lots of services and lots of ways that we can build our architecture. So essentially, we can choose an architecture and run with that, and we can build and have the front end often looking the exact same, but switching out the back end. So if you bear with me for a second, and we'll go to back to our CS230, you'll notice that in this section on the intersemester break, I added a bunch of links to lessons about how we might build a client-server architecture. And this is a client. Here's our client, our browser. Our servers are this architecture on the left, or this architecture on the right. And what I've done is I've given you examples of how you can build the same application, but running different backends. So it's a useful thing to do, and I have given you some code to get you going and working here, and there's a link to a REPL as well. And you can see, of course, the tutorials that came from Mark and Malad as well are here. So it's worthwhile reviewing some of those now as well. And essentially what's happening is that you can take your application and just keep the front end and just keep swapping out the back ends and maybe change the database. I mean, database here, this could be a relational database, but we could just as easily have MongoDB and using a collection-based database or JSON type structure. So if we want to use PHP, for example, to interact with the MySQL database, our browser talks to Apache, which makes a call to PHP, and PHP will talk to the database, and the data will move back and forward in this fashion. I mean, you can see that. So, but we have to actually, in order to be able to use PHP to talk to our database, it has to have an extension or a driver, and all software systems use this. So this allows the software package that you like and prefer to be able to make a connection and talk to the database. So, you probably have done some work at the command line using MySQL. That's just an app that's running, and it has a driver that allows it to be able to connect to the database. So we could use MySQL I, okay, that's the I stands for improved, or we can use PDO, which is PHP data object, as our drivers for PHP. MySQL I uses procedural and object-oriented forms, and PDO just uses an object-oriented form for being able to access the data. MySQLi is also limited. It only provides interaction with MySQL and clones, but PDO allows us to work with other databases. So you might have Oracle, for example, and then you start looking with PDO, and that means that you could actually retain all of your software structure and swap out the database and still be able to use a different database and just say I want to use the Oracle driver for it. So there's lots of customization available to you, but the main and the core applications often just stay the exact same. So for example, if you're using Java and you want to talk to MariaDB, for example, or MySQL, there's a driver called the JDBC, so Java Database Connectivity, that allows Java to be able to talk to your database. And you can do that from command line programs, and everything that you learn and know about Node.js or PHP will work just as well with Java for you. So, you know, you have learned a lot and you can build on all of these skills that you have already, and most programming languages work in the same kind of way. So if we want to look with the Node.js option, then we have a browser that talks over HTTP again to Node.js, and Node.js makes a connection to. So remember that your Apache normally runs on port 80 or port 8080 by default. So we often make connections and calls to here. With Node.js, we can choose the port that we want to run on. I mean, we can choose the port on Apache as well, of course, but we normally stick with the defaults. But with this one here, we can actually stick with Node.js and a port. So for example, you could listen on 3000. Sometimes I just use I use 8000 a lot of the time, or 9000 or 8001 or whatever. I tend to have this. But Node.js works in a similar way to making connection via Apache and PHP by requiring a MySQL package in order to be able to access the database. So if you want to implement templating and all the kind of stuff, you can manage that. Okay? It's not hard to do, and you'll see lots of examples of these as we work the rest of the course. So, but here are the steps that we generally go through. Worthwhile looking at these steps. So the first one is that we need to establish a connection with the database server, and we use a driver to make this happen. Or we establish a connection with the database. Here, okay? So we either contact the server or the database, and then that requires us to be able to use MySQL host name, which is the service. So web course, for example, .cs.num.e is your server. You have to have a password and a username in order to be able to log in. And then you also generally have an actual database, and that gives you access to a particular database. And once you have that, you got set up with a database, a connection ID. So if that's the case, the next steps are you can prepare all your table management. You can prepare and execute SQL transactions. Then you can process the results, which usually come back as some kind of result set. You get errors and all this kind of stuff. And it all requires your data, prepared SQL, a connection and an ID in the database. And then when you're finished, you close the database. And in order to be able to close the database, you have to have this connection identifier, the handle. We sometimes call them handles, and this connection ID. So we need to know the server, we need to know our login details, we need to know the database that we have. We use a driver in order to be able to make that connection to the server, and then that gives us an ID, and then we can use that connection ID to be able to issue SQL statements and return results. And then when we're done, we use that ID to close it. So it's fairly straightforward steps, and it works regardless of whether you're using PHP, Java, Python, or Node.js. So here's a very simple application that makes a connection to a database using procedural MySQLi. And this is the program. It's very short, And remember, let's have a look at our database first. I'm using a database here, and I'm making a connection. Let me have a look at the database that I have. So this is my database for my local host installation as organized and set up by XApp. And I'm using an earlier version, and you probably are, because I downloaded and installed this a couple of years ago. And you can see the tables that I have. I see there's this one called Node User, which I use a lot for examples. And you can look at the tables that are there, and you can see we've seen this before, the CD set, because we looked at some of those in the past. We can actually go back. And we can see the various user accounts as well that are here. We can see there's a node user here, and that your node user can get in from everywhere and can do all sorts of things. And there are other users as well, okay? But mostly I'm just using node user. So let's have a look at my example. But so generally we would need to have a host, a server name, a username, password, and a database name. Then I use these to create a connection called using MySQLi connect. And that uses the server, the username, the password, the database. And that allows us and gives us a connection. And we can connect then, we can then check to see if this, we can check for errors. We just check this, we give this variable the connection ID. I'm just calling it $con in PHP. And we can test that. And if there's a problem with this connection ID, we fail and we can just generate an error. Otherwise, we can connect. And once we've connected, we can do stuff. Now, this program is simple. It does nothing. But we can do this. So this is how we would do it with a connection. I have some examples done for you sitting here in Atom. So we can see a connection. Okay. So I'm looking at trying to connection. If I can do, here's a connection. Okay. And you can see it's very similar. I'm looking at the connection where I'm looking at, here's a connect. $con is my MySQLi host, and the username, the password, and the database name. And you might say, well, if we look at the code, all the information was here. So what I've done is I've taken out, for security reasons, I've taken out the information from the app itself, and I've put it into a file called dbconfig.php, and I require and load this once. So I can load those variables, and I don't have to have them in all my applications. So if I want to switch databases and so forth, so that's, that's fine. You can make that work. So you can see the demo here. I have just put those details here, and you can see that my host is 127.0.0. It's the local host. Node user is the database name. Node user is the username, and Node user is the password. So okay, so somebody's just asked a question there. Christian, how do you put a database in a user that you created? So you don't actually put a database in a user. You can create a database, and then you can give users permissions to be able to use that using Grant. So you can add users to, so you can create a user. So you can, if I just done a search here for adding users to MySQL database, how to create a new user and give them permissions in SQL. So I can check the manuals. Or you can just have a look at creating a new user here, and this tells you about how the commands for this. So you can log in as MySQL, and here's a command: create a user at a particular host, identified what their password is, and then you grant them access and be able to use use table. So I'd have a look at that particular one if you want. The link is here. It's very good. It's a DigitalOcean one. It's the first one that pops up when you ask that question. Adding users to MySQL database. So that's how that works. Okay. So we have this connection then, and you can see that I have my simple test my database with PHP. Now you'll notice that I'm actually creating some commands and so forth. So let me just check the connection here. Simple connection. I have anything that's really simple. Okay, here's a connection. I can just make this connection here so I can connect to the database. Okay, so this is in a file called PHP MySQL connect, and I've put this into my htdocs directory here. Okay, and this is where my demos are. You can see it, PHP MySQL connect. So I can go to localhost, PHP, called again, sorry. PHP MySQL connect. Connect.php, and you can see that I've connected to the database. So I know it works and it's fine. I've done this many times, so it that piece of code works fine for us. And now I'm just using a PDO connection rather than the MySQLi that I talked about earlier. So one other thing that you can do in order to make this work and test is to start, you can play with these on the command line. So if I look at the command line, I look at the apps, I also have PHP MySQL connect here, and I can run PHP applications from the command line in addition to putting them onto a web server, making them work. So I can do this by doing PHP, because I've installed PHP F, and I want to do PHP And I've connected here as well. So I know that that works, and we can do a lot of testing. You're welcome, Christian. You can run a lot of your command line programs for PHP on the testing and this kind of database work. You can do a lot of it from the command line. It makes life a little bit easier for you as well. So once you have the basic connection part working, then you can start working at all the HTML aspect. So this works quite nicely. It's a good command to realize that you can run PHP from the command line. Not everybody knows you can do this. Okay, so now let's have a look at this PDO connection, which I've just done actually. And really, it's a similar connection, but you know, we can do all sorts of extra stuff here, like setting attributes on the database handle. We're looking at error reporting, throwing exceptions and so forth, and making that connection. You can see this is more of an object-oriented approach. And again, I've embedded the details here in the actual in the piece of code as well, just so you have them. But it's best to take a version that looks like this, where you put the details into a separate file and make a connection. So I have a demo, for example, here where I'm able to look and query the tables. And I'm looking at trying to get something from the web course database rather than my local database. So everything else can work fine, but I can just put the details into this. And I don't want to share my login details with you, but I can show you the code. And then, you know, you can, it's much more secure in many respects. And I can also do all sorts of, you know, I can swap in, you know, maybe your details. Sometimes I'm often testing students' code, and then, you know, we just keep the code and then just test the or change the details that are in this file, and we don't have to change anything else. So 2 ways of making a connection. As I said, you know, it's simpler, but there's a good summary on w3schools.com as well if you wanted to look at something like this. But these code that I give you are fine, and they work fine, and you know, they'll be good for you. Okay, so I would use, I suppose for practice, you know, I need to know all the ways of doing this, okay? But for you, I'd recommend that you just choose one and work with one, because once it works, you know? And then use that for your study and for your assignments. Try not to do everything. And you'll notice that later on in the assignments, I will give you the option of either running and using PHP for your solutions or Node.js. And I'm not fussy about whichever one you use. So unless I explicitly tell you which one to use, I don't mind what you use for your solution, as long as we get an online solution. And it's the same when it comes to any database solution. Later on, I might explicitly ask you in an assignment to use relational database, or I might ask you to use MongoDB. But at some point then we'll get to a point for your assignment, for your exam, you can use whatever technology suite you like. You don't have to use any specific one. Just use the one that you feel most comfortable with and that works for you. More important is getting the assignment done and getting a solution, rather than how that solution is implemented. You know, so as long as you learn how to do it one way and know that there are alternatives and choices, then that's absolutely fine by me. Start with MySQLi. I mean, it's fine, it works. And that would be good. So we can actually see some demos, I guess. So let me look at what demos do I have? So here was a simple database that was able to pull something with PHP from my CD set. Okay, so I've been able to log in and pull down the details. And this one is called testdb.php. So I can either do it online. See, I could do it online. DB, PHP. Got an extra dash in there. I didn't. testdb. PHP, so that's not working. testdb.php failed to open because there's no permission. Okay, so I have a feeling I know what's going on here. Okay, so I'm looking at my test. Where is it? testdb. Here it is, down here. Okay, it's in my directory. So let me have a look at the properties of this. Let me have a look. And okay, so I can see that I have no access. I can read it, but I have no access for the web server. Web server is running as a web server. So if I change this and just make it read and write, the web server should be able to now access it. I hope. it works fine. So sometimes when you're doing this work, you'll see that you get some errors. Okay, and a lot of the error, even though you have the file in the htdocs directory of your web server, you can't access it. Because remember, the web server is running as a user, and that user needs to have permission to access the files that are there. So it's probably a good idea. But you can see that I was able to run the software and pull the information from a database. And we can have a look at the code. So all I did is once I had my connection, I then created an SQL statement, and then I used my connection to execute this query, which is con.query. I tend to refer to these arrows as dot as well. It's just easier. And so I'm executing SQL. And so if I had data returned, I can iterate over the data and pull out the various information, the data that comes, and then close the connection. And again, this particular one can run from the command line. Okay, this one here can run from the command line. Let me go and see, can I do this? Yeah, it's here. So let's see if I can run this one. PHP. Yeah, and it all worked as well. The data came back. So that's how you can run and make PHP apps work. And the PHP demo was a bit more interesting one that showed me some tables. So, and I've given some examples here how you can find tables in a database using this SQL statement, show tables from here, and then taking something from a table as well. So these are just sample programs that I'm giving you. I'll share them with you so that you'll be able to find that information for yourself and use that yourself with your examples. So let me just make this one work. So it is PHP demo, so I'll just see. I was able to find out, you know, the test table, that it existed and that there were two tables. I was able to pull out the information from the table. And again, this one will work just fine if I go to a web server. And I've installed it on a web server, so I'm not just running it locally. And it's fine. It behaves in the exact same way. So, so you can do lots of fun stuff, you know, connecting to databases. You need to connect using those credentials, and then you get a connection ID, and you can use that connection ID to be able to create and issue SQL statements. You get the data back from the SQL statements, and you iterate over your data in order to be able to access them. It's very, very straightforward. Right, so we've seen this. Have I seen all the demos of this? Yeah. So let's look then at Node.js. So Node.js, if you remember correctly, is the alternative really to doing this. So this is like building a full stack JavaScript, okay, where we don't have an Apache web server. We write the server as a Node.js app. And this one, in order to be able, we've seen those web servers running before. So now we're going to increase the functionality of that by including another library, which is MySQL, and allows us to be able to access and make MySQL calls from our Node.js. So we know about the HTTP, and later we'll see about the Express module, which allows us to be able to build web apps that are accessible and build APIs or full apps. And now we were able to extend it so that they can talk to databases, not just files, okay, or deal with something that's in memory. And it's very straightforward. We use the MySQL. Again, we create a path connection in the exact same way. You know, create a connection, localhost, username, password, and database. We make a connection using con. So con is our variable here. MySQL.create a connection, and that becomes our variable. And then we use this con.connect to be able to create a callback function that tells us whether we've connected. Again, there's a W3 Schools link on how to do this. It's fairly straightforward. But you could check out the code there. I've given loads of examples already in week 5 lectures when we looked at Ajax. By the time we focused on Ajax, we didn't actually talk that the server-side code to look at database app integration, but there's lots of examples there, and you should be able to see them. But once we know how to connect to a database, we can use it to create and manipulate tables. We have to develop appropriate architectural models, of course, for the data that's managed. And one way we can model data is using entity relationship modeling. And you should have done this with your database course. And we don't forget this stuff. ER modeling is really, really important. I'll give a small review of how to model databases as well, just so that you're up to speed fairly quickly. But anyway, once we have Node.js set up to make a connection, we can issue a query. And then we can just issue a query in the same way you know all this stuff. Select the ID, fname, lname from the test table. And then we create this callback function here. And that allows us to give us a result, and we're able to manipulate the result. So result is an object that contains the results of the query, and we can iterate over that query in order to be able to iterate over that result variable in order to access all of the data. So they all behave in the same kind of way. So this is a Node.js connection to a database. Again, this is the PHP version, which is the exact same, and we store it in a result variable. So we select something from the table, we create a link and create a query, and then we iterate over all the data here. Okay, again, we pull back the rows and we pull out all the data. So it works in the exact same way. So this is the PHP, this is a Node.js way, PHP way. The principles are the exact same. It's just knowing the language elements that arise from having a specific driver within that language to be able to make that connection. For the first part of our assignment 4, there's no HTML. Oh yeah, there's HTML probably already. I'll have to look at assignment 4, but I can get to you. But a lot of the time, the HTML PHP apps have HTML with embedded into PHP. I'm just focusing on the code part here. But if you look at the examples that I've given in the intersemester break, you'll see that. Okay, I'll have a look at number 4, and Christian, if you just send me a message on Teams, I'll come back to you. Thank you. Okay, so let's now have a look at what Node.js. We have a Node demo here. So did I load this Node demo? Node demo. So this is a connection, and you can see the connection here. I'm hiding my connection from you, details from you, because I'm connecting to web course. I'm using MySQL. I'm making a connection, and I'm selecting the data from the test table, and I'm iterating over the data and looking at the data. So this is nodedemo.js. You'll need to change it with your details. So let me have a look at node demo. Node. And I was able to pull back the information from the database. Okay. So that was the only database one, that Node.js demo here. Let me just go to web course. I've logged in, and we can look at the test table, and we can see the data. We see the data in the, yeah, okay, so we can see the data that are in the database here. There's John Keating, Joe Blogs, and they're in this test table database, which we are accessing here from, we're creating a connection. I'm not telling you, but in here we can see that the data is here, the database that we're going to connect to, and we're selecting fname, selecting star from test table, and then we're iterating over the results and printing out the result. And it told us that there were 2 pieces of information, John Keating, Joe Blogs, and if we can verify that by seeing John Keating, Joe Blogs. So our demo works. Okay. And I think it was the same one we ran when we ran the PHP demo. Yeah, we had the exact same one, John Keating, Joe Blog. Okay, we did a little bit of manipulation on this one, but essentially it was the same. Okay, so that's how we make our connections to our database. How we use the with Node.js or with PHP. So there's something to think about, and maybe something for you to research. Let me hear. Most students use Windows systems, not use Linux command line. Frankie, your computer science students, Frankie, you should really be aware of Linux as well. You will, and as I've said before, and I said earlier in this lecture, that XAMPP will work from Windows, Linux, or macOS. And you have tools that will work on the command line across all of those as well. Okay, and really you should be learning how to use the Linux command line if you want to have a career in computer science and software engineering. Okay, it's not that difficult. And it's really, really good and excellent skill to have. And saying that you don't know how to use it, really, if you say to yourself, I don't know how to use it, the answer should be, not what else can I use? Well, how do I learn how to use it? And, it's very simple, examples online to be able to use the Linux command line. Okay? Most of the time, it's just issuing simple commands in order to make this work. But, you don't have to do this. I mean, you can use and work everything from within a Windows environment if you choose to do that. And the Windows environment could be within Linux, it could be within Windows, or it could be within macOS. So yeah, it's up to you. So and I'm sure most of my colleagues would feel the same way, that you don't know something, well, then learn it. That's why you're in education, and that's why we teach computer science. And if you go to work in a company, you will be expected to know some things, and if you don't know some things, you'll be expected to learn it there as well. That's the whole purpose of having an education. So okay, so let me get on. Speaking of education and thinking about it, if you really want to understand what was happening in the last two examples, the one where I ran the Node.js demo here and I ran the PHP demo, which were two command line applications that accessed a database via an app that was running. So in one case, we had a result variable, one how we call $result. But if you think about the PHP, does it actually contain all of the data that comes back from the table? And if that's the case, would that be a good idea? So if the table contains, say, 1 million records, then could we fit a variable that large in memory that's allocated to Apache or to PHP or to your Node app? So this is why we want you to think about computer science and software engineering and really think about what's happening here. What do drivers do? What do these tools do? Would it be better to have your connection actually point to some kind of result set that contain pointers to where you could access the data iteratively as they were returned? Or is all this data just shipped back and forth every time? So in practice, we just use the database and drivers, but at some point in our computer science and software engineering careers, your second year students, most of your second year students, you have to actually understand how these things work. And it's something for the future. You don't need to know the details for this module, but it does impact a little bit later if you want to build optimized web applications. But it's a bit early in your CS career to know all the answers to this thing. You should really, but you should be thinking about it at a deeper level. Let me show you an example piece of software. So I wrote a demo, which I gave to you. Let me run this program. Okay, so I have this Ajax API demo, which is an Ajax API demo that pretends to access a database. So this was a HTTP server running a port 8000. And if I look at port 8000 here, then I have this demo. I gave this to people during the tutorials that were running in the inter-semester break, but I also posted this online. So I have this demo, which allows me to add a user to a database. So let me add this user to the database. So I've sent the data. So I've added this user to the database. Okay? And this is an example of using jQuery in the front end to make a connection across to the app and then adding the data. I can pull the data from the database here by just clicking this button. Now the reality is, and we can see the information that was pulled from the data because I have an app that does this work. And you can see the code for this, which I've given you. Here is the code. Okay, and it uses this package, sets up a piece of server, but it maintains an in-memory database. Okay, it's an in-memory database that handles all of those data. Okay, and so as it's running, I can add something else to the database. So Joe Blogs is added to the database, and I am now get the data, and I can see I've got 2 lots of information stored in the database. So this is a way I can actually create something with a form, add it, retrieve the information back, and manipulate it if I want to. So this is pretty much the assignment that you would have for your assignment 4, but this one actually just uses an in-data database. So what I've done here, we control. So I really only have 3 files, so 2 files. So I have my index.html and I have my index.js, and this is the server, and it uses and loads this as its file, okay, as its front end. But what happens if I didn't want to just have everything stored in memory? If I wanted to actually have an actual database. So I can actually use this database, so I can modify my code. So here is my index.js, which just handles and works with an inline database. It's not long, it's 108 lines long, a lot of comments. You know, it's a very short exercise. But here's my connection to an actual database. So this time I'm actually using MySQL for my database, which is different, but nothing else has changed. You know, the front end still works the same, but this time I'm manipulating and working with a database. You can see I'm inserting into tables here this time. I've got code here, and then I'm taking data back from the database, and I'm working with that. It's a little bit 50 or 60 lines more, but that's because there's an awful lot more comments in here as well to show this. So I can run this one now, and it's using WebCourse. So I can now run this one. So this time I'm connecting to my Ajax API demo, and it's connected. And if I move to WebCourse, you will see that I have this demo program here, and you can see this is the table I'm using. So I'm working with this on WebCourse. Okay, so it's an online database that we're providing for all students so that they can use for their assignments. So I'm just using it as a demo here. And so I can now come back and reload this page. Again, I'm still working on port 8000 here, but now I'm going to be working with the actual database. I can see, I know I'm using the online database because I can just click get the user database here, and I'm seeing all the current examples that are here. So I can add something to that database. Send the data, and I've added the data to the database for John Blogs, and I can look at my web course. I don't see any John Blogs here, okay? So, you know, there's loads of things here, but no John Blogs. So I'll just refresh this page. And now I can see that there's a John Blogs. It was added to the database. And if I wish, and I have my data, because I always have some local information here as well, then we can pull the data back here as well. And you can see that there's a new record. So that's a little bit about that. I mean, that code, I can share that code with you as well. It will be useful for you for your assignments, but that's how you do it, basically. And of course, I could change this database application so that it uses very easily, straightforwardly, uses MongoDB, which we'll see a little bit later. And you'll see that example later too. And I could use Express in order to be able to build a proper API. And, you know, that's pretty much everything to do with the course. So let's get back to the final part of the lecture. So what I really want you to think about is that we have some issues around modeling that's going to be really, really important for you. And I think you need to think and understand modeling data. If you want to build databases of data that are efficient, that work well, we need you to correctly and appropriately design solutions. for data. A lot of times there's focus on solving and building databases applications, and the focus is on the front end, focus on the API, focus on all that stuff. But you should never forget about actually looking at data. And so really, you need to start thinking about and understanding and remembering about data. So you did all this stuff in your database module, but you may or may not be familiar with this crow's foot notation here for the entities. And so I think, and it's important that you actually have a look and understand. For example, if we wanted to keep details on a customer, this might be, we'd have customers here as a primary key. For a customer ID as a primary key, alternate keys, and sometimes you'll see foreign keys here. So there's an ID as a foreign key, and so it's database, relational database. It's often about relations. So a customer, we might have an address, and then we have a customer address, which actually we know that this is a relation because it holds two foreign keys. So customer address and address ID. Because we may have multiple people, customers may have multiple addresses, or we may have multiple customers at the same address. So you actually have to have an understanding of whether it's a physical address, a shipping address, billing address, kinds of addresses that these are. Okay? And then we also have histories, so that we maybe be able to retain the histories for addresses and so forth. So this is a really nice model, and there's a beautiful discussion on this Stack Exchange. How do you store a billing address in best practice? And I'm not saying that this is the best way to do this, but what's important is that there's a really good discussion about how this thing works, and it's a useful thing. So I'll talk a little bit more about that in the lectures that follows, but you do need to be able to understand how database architecture happens, and the best way to build this. Most of the time you can fit something in one or two tables. Okay? But you will need to have 2 or 3 tables, place where you might have the name of a person, the people, their addresses, and their connections. So in some of the assignments I've given in the past, we might have customers visiting a doctor, and then they have addresses as well. So which doctor sees which customer. So there will be some relation. So there are 2 entities, maybe doctors, customer or patients, and then the doctor that's seeing a particular patient. And then each of those might have an address or some detail. And you might have a record or a log of visits to a doctor, or a physiotherapist or a therapist or something. So there's lots of things. So this model and understanding this model is going to be really crucial, and you should have a sense of how best implement this, either in a relational model or in a collection-based model, which we see later in when we start looking at MongoDB. Okay, so thanks for coming along. I'll have a look at some of those final questions there. Does front end need to be for assignment 4? How in depth? It needs to meet the requirements. If I ask you to provide a table that a front end that does something, it needs to just do that. I don't really care or worry about embellishments at all, but it does need to be able to at least have the data and so forth. You should have there will be some marks for styling and using styles, and for structure and layout, to demonstrate that you know how to use JS, how to use CSS, and how to use HTML, and then you have to make it connect and work. So I hope that works as well. Is IndexedDB on Moodle? I don't know what you mean by IndexedDB. Oh, that file. Sorry, do you mean it? No, it's not on Moodle, not yet. No. I'll put it up one of these days. Okay? But I'm just demonstrating in this one that you can make a connection. I'm not going to give you an answer to an assignment. I tend to do these kind of things afterwards or close, but those other files that I've given you in terms of how to make the connection to the database, how to use either Node.js or with PHP, all of the other files that are here, and these ones, they will be all on Moodle today. I'll just, the links are there. I just have hidden them currently, and I'll unhide them a little bit. So you should have demo programs that will work. Somebody's asking about the date. Read the top of the assignment. It'll tell you when the assignments are due. Every assignment has a day it's released and the day it's due. In fact, assignment 4 was released a week earlier, just to give you a little time for it. So please check the date and be sure you get it done by the date. Okay. Thanks for coming, everybody. I appreciate you being there. And, you know, as always, I appreciate the questions and so forth. If you have further questions, you can just send me a message in Teams. Thank you very much. Have a good day.